A solid brass sphere has a radius of 25 centimeters and a pressure of 1 times 10 to the 5 Pascal, which is about atmospheric pressure, and is then lowered into the ocean to a depth where the pressure is 2 times 10 to the 7 Pascal. By how much does the radius decrease given that the bulk modulus of brass is 1.16 times 10 to the 11 Pascal? Now, before I start this question, I have a cool little trick I want to share with everyone. If you have a situation involving a sphere and you're looking at, in this case, something involving bulk modulus, which involves a relative change in volume, delta V over whatever initial reference volume you have, delta V over VI. Here is some math that if you want to spend some time looking at, maybe you can pause and look at this stuff and see if all my steps are correct. But in this last step, we're going to neglect these last two terms because they're going to be really, really small if the change in the radius, that's what this delta R is very, very small. So what that means is a change in volume over volume is approximately equal to 3 times a change in radius over radius. Maybe this should be R sub I here, I don't know. But this is going to be way easier to work with for this problem than volumes. And in particular, the volume formula for a sphere, which has got all those 4/3 pi and stuff in there. So how can we approach this with this knowledge? So I'll start out by writing down the definition of the bulk modulus. It is equal to minus the change in pressure over, and I'll still start with the traditional definition in terms of relative volume change. But in light of this relationship for a sphere, it means that for this problem, maybe what I can do is substitute in a 3 delta R over R, or maybe if you like, that could be R sub I. It doesn't really matter. That's going to be the 25 centimeters there. And then see if we can calculate what we want from this. So recognizing, if we look back through this question, it says how much does the radius decrease given that the bulk modulus of brass is, etc., right? So I think I'd like to write that as a delta R is equal to the question. The way it's phrased actually is interesting though, because it says by how much does the radius decrease? I think if I literally plug in numbers into this, based on what's given to me, I'll probably get a delta R that is negative, but based on what's being asked here, I'd probably change that to a positive number, and we'll see how that turns out. One of the things that with the numbers that I am given here is I think I can calculate what the change in pressure is, because that would be final minus initial is always what change is, and in this case that would correspond to 2 times 10 to the 7 Pascal minus 1 times 10 to the 5 Pascal based on the numbers that are given to us here, and that winds up being like 1.99 times 10 to the 7 Pascal, and I haven't rounded that off yet there. And then again, recognizing I'm being asked for delta R. So let me look at this original formula. I don't have a lot of space here, so I think I'm going to have to be a little bit abbreviated and maybe showing some of my steps, because what I'd like to do is algebraically solve for delta R, and I think I'm just going to try to write the correct answer here by things like cross multiplication, because if I imagine multiplying delta R on both sides, dividing by B on both sides, I would have something like minus delta P on top divided by 3 times B, and then I'm actually going to migrate this R sub I that's down here and just multiply that over here. It turns out that's algebraically correct to do. And again, if you want to maybe work through these steps on your own in some more detail to see if this is correct, I'd encourage you to do that, because sometimes it's good to just make sure you know how to do that. I'm sometimes limited in space on this screen to be able to show everything. But at this point, I think I can take these numbers and plug them in, and maybe I'll just be careful with the units a little bit here, because this is 1.99 times 10 to the 7 Pascal that I'm plugging in for delta P. Let me not forget that minus sign. All of that's going to be divided by 3 times 1.16 times 10 to the 11 Pascal. That's cool. Looks like those units are going to cancel there. And then the radius I'm given there is 25 centimeters. I could leave that as 25 centimeters, but I thought maybe it'd be fun to just put it in as 0.25 meters, put everything in base units for now, even though you don't have to do that. If somebody else left it in centimeters and just track the units, that's fine by me too. Fine by anyone, really. Anyway, so I'm going to put all that in my calculator, and the result I get for that is like minus 1.4029. Let's round that off to just 43 there, because I think I actually need less than that in the final answer anyways. Times 10 to the minus 5 in meters, which at this point, I'm going to go ahead and look at this. And if I multiply this by 1,000, that would give it to me in millimeters, since it looks like this is kind of a small number. Millimeters might be a good unit here. I don't know. I get minus 0.014, maybe rounding off to two significant figures now. Millimeters for that. Let me write down over here, though, just given the way this question is phrased. I mean, maybe it's okay to write it this way. This really is what delta R is, but since it's asking for how much does the radius decrease by, that really would be a positive 0.014 millimeter, and so maybe I'll put a box around that to distinguish it from everything else I just did and make clear that that's what I think the answer is. Let's go ahead and check, and it looks like we're golden there.